Well,
No.
they would miss it.
The remote class, I like make a prepared video, and it covers the whole week of material in one video.
Teachers should like edit their online class.
Like
videos.
cool edits.
Yeah.
Like and
have
subscribe.
transitions with, like, the whole time, it's just- yeah.
Yeah.
It's like jazz music in the background.
Cool transition. Okay. Let's just go over some answers to the first page.
Can we do K?
Okay. So, and then we're going to talk about number 2. But so a number 1, so you'll have to follow, if you're, for the millions of viewers at home, you'll have to follow along on your paper here. So we discussed, so let's quick review. When you're looking at a limit, a lot of times you're either asking for limit from the left, right? So from the left, there's from the right, right? Now, if they're approaching the same value from the left and from the right, does the limit exist?
No. Yeah.
It does. Okay, the limit would exist in this case.
Oh, if they're the.
Like we talked about yesterday, the answer to G is 1 because the limit from the left and the limit from the right were both 1, okay? But the limit at 5, so the answer to C does not exist because the limit from the right was 2 and the limit from the left was -1, okay? Are there any questions on that?
No.
So what's the answer to K then, Mime?
Wouldn't it just be, I don't know, does not exist. No, limit exists, it's at 4.
It's 4.
Wait, hold up.
Big brain. Big brains.
Why wouldn't it be 1?
So
That's what I was confused about.
because, okay, so on this graph, here's a little mini version of the graph. It's going up and approaching this hole, right? That hole is at 4. The dot is down here at 1. So it looks kind of like that, right? At least in that little neighborhood. So what happens, now again, when you look at a limit, do I really care when I write this, for example, do I care what's happening at -1 exactly?
No.
No, I do not. I care about, in this case, I'm caring about numbers like -1.00001, a number just barely to the left of -1. If I was looking at a number just barely to the left of -1, where would I be on the curve? I'd be like right there. I'd be just to the left of the hole, right?
Right at the other point though. Or is that just a random point?
No, I'm getting there. So this answer is 4. So if you plugged in this number, you'd get very close to 4. What if I plugged in a number to the right? What if I went the limit as x approaches 1 from the right? Where would I be there? Again, do I care about what happens at -1 exactly?
No.
No, I do not. I care about just being barely to the right of -1. So for example, a point like -0.99999. Again, what would my y value be if I plugged in a number just barely to the right of -1? Awfully close to 4, right? So what that tells me is that the limit as x approaches 1 is 4. So this answers questions I, J, and K.
So
I, J, and K. But question L asks, okay, great, you're telling me about the behavior of the function really close to -1, but what if I was asking what actually happens at -1 exactly? That's how you write that. You say, what is actually f of -1? This dot tells us that the answer to that is 1. Okay? So what happens on this function? You're moving along. As I move this direction, what are my x values getting really close to, guys?
1, -1.
They're getting really close to -1. But when I actually hit -1, I jump down and hit this point, and then I come back And now if x is a little bit to the right of -1, I'm back up to this 4 value. How do we feel about that? Yes, no, maybe so?
Yeah.
Just weird.
Yeah. Yeah, it's not like
What's the purpose of that point there?
the point is just say, well, the word purpose is kind of I don't know if you can say a point has a purpose, but
Or like we've not.
say the person making the function wants a function that, for whatever reason, instead of doing this, I can give you an example. I'm not sure if this will help what you're asking.
Okay, then that's fine. Because I don't want to get more confused.
Well, I mean, this shouldn't hurt. Can you imagine a function? I say I graph a function and I go, okay, I want to graph a function, that simple function like y equals x plus 2 or something. And I say, just for some reason, I don't know why, I'm just feeling crazy, you know, I want to say, well, actually, when we get to say x equals 3, I don't want it to follow that same pattern. I want it to be like 1 less. I would just put a dot below. And so in this case, let's say this was basic, this line was like y equals x plus 2. Then what I'd say is, well, as I approach 3, what do you think the limit would be if this was x plus 2 and I was awfully, awfully close to 3? What's my limit here? It would be 5. It would be 5. Because let's say x was really, really close to 3 and you were on this curve, you'd be adding 2 to that.
Okay.
So you'd be awfully close to 5. So my limit would be 5, but the actual y value could be like 4.2798, whatever, any arbitrary number I wanted it to be. I can just make that up.
So like,
You guys okay with that?
if there's an asymptote on, let's say like, for example, I'm looking at R, there's an asymptote on 3 and it's like as x is approaching 3, wouldn't that just not exist?
Good, very good, yes.
Right. Okay.
Okay, let's finish the rest of the answers here. So, and feel free to stop me if you have any questions, okay? But, so question I was 4. Question J was 4. Question K was 4. Question L was 1. All right, let's go forward here. Let's go to question M. What is the limit as we approach -4 from the left?
Isn't it just
1.
1. What's the limit as we approach -4, from the right?
1?
1. What's the limit as we approach -4 then?
1.
1. What's f -4? F of -4? 1. Are there any questions on that? By the way, do you guys maybe know the answer to this? What kind of behavior of that is that? It starts with a C. If you have a function that's like there's no jump or gap or anything in it, it's just nice and smooth. Kind of continuous is actually. You guys heard that word before? Continuous. So when the function's nice and continuous, all the values are the same. The left limit, the right limit, the limit, and the y value are all the same number. Is the function continuous at -1, like this thing we were just talking about? Is that continuous?
No.
No. So the limit, sure, the limit could exist, but was the limit the same value as the actual y value?
No.
No. So that's not continuous. Okay, let's keep going. How about the limit as x approaches 0? Question Q.
Wouldn't it just be 5?
5, very good. How about the limit as x approaches 3?
Doesn't exist.
Yeah, so that asymptote, if you wanted to get fancy, there are some math textbooks that might say a statement like this: the limit is -infinity. But
Because they're both going negative?
yeah, because they're both going to the same -infinity. But to keep things simple, if you put this in plain language, is there any limit to the y values? No, it's limitless. It goes to -infinity. So you can't be equal to infinity. It's not a number. So what you can do is if the function's ever going to infinity, positive or negative, you can just say the limit does not exist. Cool beans?
Wings. So then f of 3 would just be undefined.
And then f of 3 is undefined. Again, if you said f of 3 does not exist, you're not like way off or anything. It's just for some reason, people typically say that f of 3 is undefined, meaning you cannot even plug that number into the function, whereas the limit, we say the limit does not exist, that actually contains some extra information about what the function's doing there. How about f of 0? 5. By the way, is the function continuous at 0? You guys think?
Yes.
Looks pretty continuous to me. How about the limit as you approach 6?
3?
3. How about the limit as we approach infinity?
I have no idea. Greater than.
What do you think it means if we say as x approaches infinity? Does that remind you of anything? End behavior. So as x approaches infinity, y is approaching infinity, so you can say does not exist. Could you get away with saying the limit as x approaches infinity of the function is infinity? You could probably get away with that, but it's just as easy to say it does not exist. Okay? Let's answer what?
Oh, I was trying to page.
Okay, let's look at 2. I have carefully drawn it on the board for the millions of viewers at home on Twitch. Thanks for the 5 gifted.
Do you ever just awkwardly stare into the camera to make them uncomfortable?
Just a little now on them. All right, let's look at this here, guys. So, what's the limit as we approach 0 from the left?
2.
So the notation is approaching 0. Remember that little minus means from the left. Here I am, I'm approaching it from the left. What am I hitting? I'm approaching 1. Cool beans?
Yeah.
How about as we approach 0 from the right?
2.
2. Now those combined, I said this the other day,
DNE.
you're going to see this a lot. If the function's it's approaching 1 from the left and 2 from the right, the limit does not exist. Are there any questions on that idea? Okay.
I've been thinking about it, and so it makes more sense.
That's good. I'm glad to hear you thought about it. How about f of 0? What is actually f of 0?
2.
2. Very good. All right. How about at 3? What's the limit as x is approaching 3 from the right-hand side?
4.
4. What's the limit as we approach 3 from the left-hand side?
4.
4. Is everyone seeing that right here?
Yeah.
Approach, you're approaching the same exact y value. However, well, actually, sorry, let me finish this. So what's the limit then? Does the limit exist?
4.
Yeah. If the left limit and the right limit are the same number, then the limit exists every single time.
What do you write?
They just say this. You said it equals. You say it equals 4. However, what is f of 3 though, according to this graph? It's 0 because of this dot. That dot right there tells us that f of 3 is 0. Okay, the last 4 are. These are actually kind of throw people off once in a while. Like, what's the limit as you approach 4?
1.
1. Does it matter there's no big fat dot there? No. If it makes you feel better, you can draw one. A dot just means the point exists there. So the limit as you approach 4 is 1. What's f of 4?
1.
1. What's the limit as we approach negative 2?
Doesn't
Does
exist.
not exist. How about the limit as we approach infinity?
Undefined.
Yeah, the limit as x approaches infinity, I guess, I mean, it's a picture, so you can never be 100% sure, but the picture seems to be suggesting that the function comes down asymptotically and approaches 0. So the last answer is that. Okay with that, Kira? Getting caught up? Feel good? Okay. Huh? You haven't gone as much as Kira. As much as I'm glad to have you back here, Reese. Okay, so number 3.
Do you think that if we get earlier out?
I think we're early.
Okay.
I think that's right.
Anyway, sorry to interrupt.
Okay, we still got 5 minutes here. Number 3, we'll have some work time tomorrow in class. I don't think you'll have too much trouble. I'll give you one example from 3, just so you have one thing to work on, I guess. 3 says, sketch the graph of some function f with a domain of all reals, if possible. There might be one on there that you actually can't make the domain of reals. So that's why the if possible is there. Such that these conditions are met. So each one is a separate set of conditions. So 3a, how could we have a function where the limit as x approaches 2 is 5, but also f of 2 is 1? Let's think about that for a second.
It would have to, like, there have to be a hole on the thingy and then a dot, another point underneath it.
Very good. That's an excellent answer.
Wait, explain.
Okay.
Oh, I get it.
Put some little hash marks in here. So let's cover this part first. So the first thing Paige said was there's got to be a hole on there, because if the limit exists, the function must be doing this, right? It must be approaching the same value from the left and from the right. And it needs to be approaching a y value of 5 when x is approaching 2. So you can take this and start by putting a hole at 2, 5. The rest of the graph can kind of look however you want. It doesn't really matter. It can look like anything. You can just do a straight line, I guess, if you want to be boring. But do you guys see how this graph satisfies this description?
Yes.
And then you have to put the dot at 1.
Very good.
Oh.
And then f of 2 has to be 1. So
Makes
then,
sense.
there we go. So like I said, tomorrow in class, I'll have some time to work those out, and hopefully you'll learn something from, we're not done yet. Last thing.
If it doesn't exist, does that just mean it's an asymptote?
That's one way. So right now we know 2 ways for a limit to not exist, right? Vertical asymptotes and jumps. So on that problem, you might need to throw a jump in or a vertical asymptote depending on the description. All right, guys, this will be really easy though. Okay, so look at 4.
Like,
Number 4. So these ones that have so sometimes it doesn't say f of x, it actually gives you like what the function is. So this first one, what kind of structure does this, if you were to graph this, what kind of structure does this guy have at 2? Hinty, hinty.
Yeah.
If you were to graph this, it has a vertical asymptote at 2, right? So what's the limit as we approach 2?
Like, doesn't exist.
Does not exist. Make sense?
So
So do I actually have to graph the entire thing? No, I just have to recognize that because of the denominator, there's a vertical asymptote at 2, which means the limit at 2 can't exist. Compared to this one,
the answer is this limit does not exist.
yeah, and the answer is does not exist. The second one,
Be -5.
Well, if I like, is there anything happening weird at 5? No, the bottom's 10, the top is 0. So what you do on these is always plug the number in and see. If you can plug the number in and just get an answer, like plug 5 in, you get 0 divided by 10. The answer to that one's 0. And then I'll cover some more of them tomorrow, but that's all. That's at least a good intro into how these work.